Next one is stereochemical aspects of nucleophilic substitution reactions. Clear? So we have studied in the SN1 reaction and SN2 reaction. In the SN2 Walden inversion we have studied. In the SN1 reaction Racemization product we have discussed. Clear? So these terms belongs to stereochemistry. So that's why we have to, before going to discuss about those concepts, we have to discuss some basic concepts of the stereochemistry. Then we can understand what is the racemization product. Clear? So first one, optical activity. First one is optical activity. First one is optical activity. So many are there basic concepts like optical activity and chirality, retention configuration, inversion configuration, and racemization, racemic mixture. All we have to discuss one by one. Clear? First one, optical activity. What is optical activity means? And we will take the ordinary light here. Which light? Ordinary light. Clear? When ordinary light is passed through the Nicol prism, this we will call as what it is, Nicol prism. Ordinary light have the oscillations in a different direction. When passed through this Nicol prism and gives light oscillations, it produces the light having the oscillations only in one direction, and that light we will call as a plane polarized light, or can also be called as a PPL. This is plane polarized light. This plane polarized light having the oscillations in only unidirection, one direction. When this plane polarized light is passed through the solution of the compound and rotates this plane polarized light, this compound, if it rotates the plane polarized light, and that compound we will call as a optically active compound. Optically active compound. If it rotates, if suppose this is the plane polarized light, when we pass through this solution, if it rotates this plane polarized light like this direction or like any direction, towards the right or towards the left, and that compound we will call as optically active. But when we pass this plane polarized light through this solution of the compound, if it does not rotate the plane polarized light, you see direction like this and it is not rotated, that type of compounds we will call as optically inactive compounds. If the compound rotates the plane polarized light towards the right direction, and that compound we will call as a dextrorotatory compound, is represented by the small d r plus. And if the compound rotates the plane polarized light towards the left, that compound we will call as a levorotatory compound. Clear? And these two, clear, the D and L form of the compound is called as a optical isomers, and that property we will call as a optical isomerism. Clear? And now conditions for optical activity. Which compounds shows the optical activity? Means which compounds rotates the plane polarized light. Clear? And here two conditions are there. The molecule should be asymmetric. Means the molecule should not have any type of symmetry. Clear? Suppose if I take this compound, suppose I will take, and here COOH and H and OH, another compound I will take, means same compound, the compound I am taking here, this is. See this compound? This compound is having which one here? Plane of symmetry. If I cut this molecule in this way, exactly off you are getting. And this molecule is having the plane of symmetry, and that molecule is a optically inactive. Why? Because the molecule should be asymmetric. It should not have any type of symmetry. Clear? That is the first point. It is optically inactive because it is having the symmetry. Next one, mirror image of the molecule is not superimposed on the molecule. Clear? Means if you take simple example, if you take the right hand and left hand, you know these two are the mirror image of each other. Clear? And if you keep the mirror here, and this is the mirror image of the first one, this one. Clear? And then you put the mirror image on the molecule. You see here, mirror image on the molecule. Is it superimposable? No, it is not non-superimposable. And those type of molecules are objects we will call as a, that those type of molecules will show the optical activity. Clear? And means, suppose if I take here 0, one object I have taken here 0, and take mirror image of this one, what you will get here? 0. And put this is over the first one, exactly it is a what? Superimposable. So that's why this object we will call as a, what it is? Optically inactive. Means it should not be mirror images. Clear? So that's why these two conditions are, if a molecule having these two type of conditions, that molecule or that compound will show the optical activity. Clear? Next of these are some definitions. Chiral carbon, asymmetric carbon or stereo center. A carbon with 4 different groups is called as a chiral carbon. If you take the carbon, if carbon is attached to the 4 different groups and C2H5 and suppose Cl, and this carbon we will call as, you see this carbon is attached to 4 different groups HCH3, C2H5 and Cl, and this carbon we will call as a chiral carbon. This carbon is called as what it is? Chiral carbon. Clear? Because the carbon is having 4 different groups. R can also be called as asymmetric carbon, or this center we will call as a stereo center. Next one, chirality. What is chirality? An object or molecule that cannot be superimposed on their mirror image is called as a, what it is? Chiral molecule. And my molecule are chiral object, and the property is known as chirality. Just now only I mentioned superimposable. I have taken here left hand and right hand. Clear? And the one is, both are mirror image of each other. If I put mirror image over the molecule, these are not superimposable. And don't think that this is mirror image and mirror image of this is, if I keep the mirror in between, and this is the mirror image of the first one. If I keep like this, these are superimposable. No, the facing, you see, this is in this direction. You have to take in this direction. Same direction you have to take. If you take like this, no problem. Put the mirror image and both. See, white both white should be, means fingers should be towards you. Or if you take the mirror image, both fingers should be back side like this. You have to take the mirror image like this. You should not take like this mirror images. The facing is opposite direction. Clear? Both means the facing should be towards you only, or towards the back side. Clear? Like this you have to take. If you take like this mirror image, then it is a superimposable. You should not take like that. Clear? So that is superimposable. That objects we will call as a chiral objects, and that molecule we will call as a chiral molecule. And that property we will call as a chirality. Clear? Next one, enantiomers. Clear? I said here one is objects. Here I will take the one compound. If any compound, suppose hydrogen is here, and this is a CH3 and C2H5 and Cl. If single stereo center is there, chiral carbon is there, if you take the mirror image of this, it always not superimposed on that mirror image is not it is not superimposed on the molecule. Always you can say, and CH3. It is only for the single chiral carbon molecule. Take this is mirror image of this is this one, and put over here, then it is not superimposable on the first one. I will say how to do, not like this. I will say exactly for the molecules how to superimposable. I will discuss, and then you will get the clarity. Suppose here only I will discuss. I will take the one asymmetric molecule. Means asymmetric means what it is? It is a not having the chiral carbon. Suppose you see, I will take CH3 here, and there is another CH3 here, hydrogen, OH. What is the mirror image of this one? OH here, and C and CH3. Objects we can easily take, but how to take mirror images for the molecules? And this is hydrogen. You see, OH and OH, they are in this direction. Hands, you see. You should not, hands should not be like in this direction. Both should be, means towards you or it towards back. Clear? So here, OH is right side and this OH is left side. It should not be like this. Both should be in the same direction. So now rotate this one 180 degree. Then what you will get? OH again you will get here. Front one comes back and back one comes front. And here, previous it is there. This will go there. Means CH3. And here, what you will get? CH3H. Clear? Same you see. CH3 it is back. It is front previous. This will go back. And this is back to back and it will come front. That is all I have written. Take this molecule and put over the first one. See, exactly it is superimposable. And these molecules we will call as a, chiral molecules. Means what it is? Mirror image, but what it is? Superimposable on molecules. Superimposable to each other. So that's why those type of molecules we will call as chiral molecules. Clear? So if I take here 4 different groups to the CH3 and I will write here C2H5 and H and OH. I will take the mirror image of this one. What you will get? OH and C, and here what you will get? CH3 and here C2H5 and here what it is? H. And because OH is the right side and this is left side, both should be in the same direction. Rotate 180 degree. Then what you will get? Here OH. It is a front towards you, front side. And 180 degree rotates. It will go where? Back side. Back side means dashed line. C2H5. CH3 back side. 180 degree rotated means it will come front side. And then hydrogen on the plane. Yeah? Now take this molecule and put over the first molecule. Yeah? See here. CTH5 previous year which one? Front side. If I keep this molecule, CTH5 is where? Back side. Both are not superimposed. And here CH3 previous back. Now it is coming where? Front. One is back. If I keep the CH3 is coming back. Clear? So that's why it is coming. One is back and another one is front. So that's why these are not superimposable. So that's why if the molecule having one chiral carbon, if more than one means sometimes it is superimposable also. Clear? One chiral carbon molecules and mirror images are never superimposed. Clear? And these we will call as a mirror images and non-superimposable, and that we will call as a what it is here? Chiral molecule. This molecule we will call as a chiral molecule. Why? Because these are mirror images but not superimposable, and that property we will call as a chirality. Clear? Now enantiomers means these are enantiomers are stereoisomers which are non-superimposable on their mirror images. Now chiral means it is belongs to one molecule. This molecule is a chiral, or one object is a chiral. This object is a chiral because it is having the mirror images but non-superimposable. If you take enantiomers, these two we will call as a enantiomers. Pair of isomers. Enantiomers means two. Always remember. Enantiomers means more than one. These two we will call as a pair of isomers which are non-superimposable on their mirror images are called as a what it is here? Enantiomers. These two we will call as enantiomer. This molecule we will call as a chiral molecule. That is the difference. Clear? Next one. Enantiomers means they will have the almost all physical properties are similar, like melting point, boiling point, refractive index, all will be same. But where they will show the difference means in the rotation of plane polarized light. If it rotates the plane polarized light towards the right and it rotates the plane polarized light towards the left. Clear? So they differ only in plane polarized light. And next one, racemic mixture. What is the racemic mixture? A mixture containing two enantiomers in equal proportion in a one mixture, and if it is these two are enantiomer, this is 50% and this is 50%. These two isomers are exactly present equal amounts in the mixture. That mixture we will call as a racemic mixture. Remember, racemic mixture is optically inactive. Why? Because you know this is a one isomer, optically active. It rotates the plane polarized light, and exactly this molecule also will show the optical activity. Suppose it rotates the plane polarized light and plus 20 degree, it rotates the plane polarized light minus 20 degree. If equal amounts are there, plus 20 minus 20 become a 0. Okay? And these type of molecules means racemic mixture is what it is, optically inactive. Why? Because the rotation of one molecule is exactly cancelled by the rotation of another molecule. So that's why these are optically inactive. Okay? Next one, racemization. What is the racemization? The process of conversion of enantiomer into racemic mixture. You have to convert the enantiomer into racemic mixture. Means make the enantiomers off, then it will become, means 50% should be present. One is 50 and another one is 50. If you make it like this, then you will get to what is racemization. Means the process of conversion of the enantiomers into racemic mixtures, and that we will call as a